I'm David Bork, and our project is Mkvsynth, which is away or use it.
Oh, sir.
All right. Absolutely. Mkvsynth is a video processor for Linux. I don't like the mic at all. So, figure out how to hit next. It's really a 5-part program. So you get the input, or rather you use a script in a language that we have been working on. The language is designed to be sort of like a heavy subset of C. It's a little bit different syntax. Luke built the interpreter for the language. It reads the script, figures out what you want, and sends commands to the Jarvis library, which is sort of the core application that handles everything. Jarvis talks to a bunch of filters, which draw some of their functionality from the color spacing library. And then all the filters work together to produce your output, which is hopefully a better video than the input video.
Alright, so this is what our scripting language looks like at present, and it has most of the features you'd expect: control structures, loops, so very C-like braces and semicolons, and we do fun stuff like recursion, and we have, I guess, sort of packed in methods. They're not really methods, but you can use that dot syntax, and it'll essentially just shuttle the argument on the left between the parens. But it works. So yeah, this was my pet project. It started out as a really just awful, abysmal implementation, and I was using Perl as a transpiler into C, which would then be recompiled and executed. That was our method. So I don't know if last time we gave a presentation, I think I brought this up, and maybe did anyone here suggest using Lex or Yak or Bison? Someone did. Okay, I'm sorry I didn't listen to you because that was a much better idea. So over the summer, I found these tools, and it turns out they're really great for creating things like interpreters. Flex is an electrical analyzer, so reading tokens, and Bison is a parser, actually a parser generator, so you can read in those tokens and execute corresponding C code. Okay, I think it was demo C to set up. No, I can do that. Just give me a turn. Preferably running our program. Got it. Okay, so you have this interactive interpreter, and it's got all these cool features. So I'm really proud of it because I came in knowing basically nothing about a filer or interpreter design, and it's pretty cool. I'm proud of what I was able to make. So you have things like scoping, and you can define functions inside of functions. That took forever, but it works. So it's pretty cool. Is Eric rolling?
Yeah, just do it.
This is hard to see. Alright, so if you call power 10 times, it's able to look and see the scope that is encompassing it and see the X variable even though it's not locally defined. So I've actually never tested this, but it should. It should work. Let's see. Okay, so print 2. Awesome. So incremented 10 times. That's magical. That's my demo. So I'm going to be working some more on improving the interpreter, add some new features that David wanted, like multiple return values and functions. And really at this point, like we said, it's kind of just like an interpreted C with our own functions built in. So we want to add things that actually make it useful to use for video processing, you know, syntactic sugar and that sort of stuff that you see in the Mkvsynth scripting language.
Okay, so I've been working on the color spacing. Right now we only support RGB and YUV, and I believe at some point in time we're going to be trying to do HLSV. What my part does is it just takes usually a pixel, and that's in the formats, and it can convert it to the other one so that other functions can look at it and modify the values based on what they think they should be. It's interesting because I don't know if you've ever worked with color spaces, but YUV can make colors like super red that don't actually exist, and negative green and super blue, which is interesting to deal with. So that's about what I'll be doing. You can see an example of the functions we're going to have for interacting with RGB color space. There will be similar ones for YUV and any other color spaces we decide to include by the end of this.
Alright, I've been working on Mkvsynth core, which before was basically, it was single-threaded. It was a set of functions that just kind of called in sequence, and it was disgusting and awful. Now it's actually what I think is a really cool set of, I don't know what to call them, functions, I guess. But so basically, what it starts with, you have your video. It's a file. You pass it to a decoder. It does things in what's called frame streams. So it'll pop. Obviously, you can't fit an entire, say, like 2-hour video in your RAM, because in raw form that would be like hundreds of gigabytes. So it only does a few frames at a time, one frame at a time. It goes to one filter. Each red box represents a filter, and one of the cool things is that they're all in different threads. So all the filters are multi-threaded, and then you can see the line of little black boxes. That's what each of the little boxes represents a frame, and so it buffers them, which means if one filter is running super fast, it can sort of build up a buffer of frames. But then if the buffer fills, there's a semaphore, so it'll stop processing, and it won't fill up your RAM. And oh yeah, the green squiggle does the decoding of the initial video. Alright, we're going to do a demo though of. So right now what you have to do is you have to cat your script to Mkvsynth, because it doesn't take a file in. So what it's doing here is it's decoding the video. It's opening about. So let's look at that script. It's opening like 6 different filters, and then it's encoding 2 different videos. And we start with. This is the input. Oh, we're full screen. That's why. Let's try that again. There we go. That's the input. Almost done. And then this is the first output. A lot shorter. And the second output is, oh, it was squished. So, thank you to everybody. Don't Travis Sullivan, and all of you guys.
Oh yeah.
Yeah, absolutely. Exactly.
Are there any questions?
What is YUV? So,
Well, I could probably explain it better. So, way back when video processing was new, you had these raw videos in RGB that were super big, and so you'd compress them into like a JPEG format, but they were still too big because, you know, resolution and video is a lot of information. So one of the like great ideas was to split the video into its lightness components and its color components, because the human eye is more sensitive to brightness than it is to actual color. And so YUV stands for brightness, green and red.
blue and red.
Blue and red, thank you. And normally you do something called subsampling, so you have 8-bit depth, but the lightness is captured for every single pixel in, say, a 1080p film, and Blu-rays are actually done this way. And then the color will only be like every 4th pixel. So out of every box of 4, it's only like the upper left corner that they sample for the color. And so you have in brightness a 1080p video, and then if you just look at the color, it's actually a much smaller video. And that initially helped with compression. As it turns out today, the algorithms for compression can use pattern predicting to they're actually compress it better at higher quality if you keep the original resolution and you don't subsample.